for the 9th problem of the final, it says draw Lewis dot structures for CF4 and NF3. Identify shape and bond angles for each molecule. So for CF4, it's going to be a central C atom with 4 F's around that. And you have C, which is 4 valence electrons, and F has 7. So you're going to get 32. So that means you're going to just fill in here. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. The bond angle for this, since it has 4 atoms around the C, it's going to be exactly 109.5 degrees, and it is a tetrahedral. And then you have NF3. So here you have the central N, have 3 F's around, and N has 5 valence electrons and F has 7. So you're going to have 21 valence electrons. So just start filling it around. 2, 4, 6. Get the octet, so you got to put 2 on that N. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Oh, I don't know why I put 21 here. It's a 26. And this one, since it is a pyramidal, is going to be less than 109 degrees. And B, it says use your diagram and the VSEPR theory to explain why the bond angle of NF4 or NF3 is smaller than the bond angle of NF4. So in CF4. In CF4, you have a tetrahedral, so all of these repel off each other and repel off the nucleus evenly because these all have the same nucleic and like electron charge. So they're gonna all space out evenly, making it 109.5 degrees, which is like, I don't know, it's gonna look like this. Like evenly, I can't really draw 3D, but the bond angle for this one is going to be smaller because if you have an N here, all of these F's are going to be on the bottom, and they're going to have the 2 electrons that are traveling in like a pattern like this around the top of N. And basically, since the electrons have like a full negative charge, they're going to repel. They're going to have more of a repulsive force against these 3 F atoms, causing the F atoms to force down, making a smaller angle here, if that makes sense. So it's like basically repelling the atoms away from these 2 electrons because these 2 electrons have a negative force. And like in the CF4, these all have the same like positive forces. They all have, so like F has what? It has a nucleic charge of 9 and an electron charge of 9. So they're all gonna repel the same, while here it's not. Like these are gonna repel off these 2 electrons more because of the 2 electrons. So how would I word that? Say. Yeah, this is called a lone pair. And because the NF3 has a lone pair of electrons, the F ions repel off of the lone pair of electrons on N. I said no. Making the bond angle smaller than an F force. That's it.